Good morning to all of you. Myself, Dr. B. Prakash, working as assistant professor in the Department of Mechanical Engineering. Today we discussed about the vapor absorption refrigeration system. In this vapor absorption refrigeration system, the basic principle, as they say, from heat transfer from the low temperature, heat transfer from the low temperature to the high temperature. And this mainly the difference between vapor absorption and vapor compression system. In this vapor absorption refrigeration system, we try to completely elimination of the moving parts or noise producing device. That is simply we are trying a completely elimination of compressors. Just it is replaced by some of the pumps, and it is the compressor is replaced by the pumps and absorber and a generator. How these the commonly used in this vapor absorption refrigeration system is the ammonia is used as a refrigerant. In this simple vapor absorption refrigeration system, just we observe the schematic diagram. In this schematic diagram, low pressure and low temperature of the liquid refrigerant leaves from the expansion device, and the low pressure and the low temperature of refrigerant is allows to the evaporator where heat is absorbed from the substance, and the low temperature and the low pressure of the refrigerant, low pressure and low temperature of the refrigerant, which is converse the low pressure and low temperature of the vapor refrigerant, and the substance is attains the required temperatures, and low pressure and low temperature of vapor liquid refrigerant is converted to the vapor refrigerant. The low pressure and low temperature of vapor ammonia it is enters into the absorber. In this absorber, the absorbent is we use as the H2O water as the absorbent, and here the low pressure and low temperature of the vapor ammonia it allow enters into the absorber. It is formation of the strong solution. The strong solution of the ammonia refrigerant, which is pumped by using very small capacity of the pump and enters into the generator. In this generator, it is heat is supplied through the waste heat or some of the steam or some heating coils. Here, the strong solution is it is the ammonia is the pure converts the pure vapor form with the superheated vapor form. In this vapor refrigerant is leaves from the generator. If is there any the absorbent, that is H2O, the weak solution, hot weak solution is leaves from the generator, and then it is passing through the pressure reducing valve. The hot weak solution it is converts the low pressure and low temperature of the weak solution and enters into the absorber. So that here it is one of the major advantage to take this amount of the heat into the absorber itself, and very high pressure and high temperature of the vapor refrigerant leaves from the generator and enters into the condenser, where in the condensation process we use the cooling water as the coolant, and these vapor refrigerant is converts the high pressure and high temperature of the liquid refrigerant. This high pressure and high temperature of the liquid refrigerant, it enters through the reservoirs where it is accumulation of all the liquid ammonia refrigerant, and this one is passing through the expansion device. The through these main the function of the expansion device, which is converts the high pressure and high temperature of the liquid into the low pressure and low temperature of liquid refrigerant. So that once again it is enters into the evaporator, the cycle is a repeat. That is simple vapor absorption refrigeration system. And then in the practical vapor absorption refrigeration system, just we observe this is the practical vapor absorption refrigeration system. Just we observe the say as usual the as the same as the simple vapor absorption refrigeration system. Yeah, in this simple vapor absorption refrigeration system, we add some of the new components, analyzer and two more exchangers, heat exchangers, and that is and a rectifier also. The analyzer, which is integral part of the generator or it is a separate part, it is located at the top of generator. This analyzer it consists of a series of plates, and main function of the analyzer, if is there any absorbent, that is the water vapor it leaves from the generator. It is try to eliminate maximum the absorbent in the analyzer. And the rectifier, it is the one of the rectifier or a dehumidifier. In this dehumidifier, we are trying to complete maximum with liquid, the refrigerator, the absorbent. If it is we allow the absorbent, the condensation temperature, the absorbent is we use is the water at 0 degrees centigrade. Water is converts the theoretically water is converted to the ice, so that it blows the all the pipelines or choking the pipelines, so that it is the major by considering of the major disadvantage, we try to complete elimination of the absorbent the portion in the rectifier itself. And we use the heat exchange two heat exchangers. One of the heat exchanger we located in between the generator and absorber, and one more heat exchanger it is located in between the absorber and evaporator, and a receiver and evaporator. The main thing is we try to utilize the maximum heat energy, and based on the usage of the heat energy, we try to reduce the heat input into the generator. That is main the our intention. So that we try to explain the thing here. Hmm. From the generator, it leaves the strong the ammonia vapor only, that is the refrigerant, vapor refrigerant. If suppose it carries the any mass of the absorbent, it is tried to elimination in the analyzer itself. These analyzer from the analyzer it sent to the rectifier. Here this is the dehumidifier. The cooling water used as the absorbent. If is there any water vapor or absorbent here, it is try to convert the water and drip to the into the analyzer once again, and we leaves only the pure vapor refrigerant from the rectifier or dehumidifier. The dehumidifier, this pure refrigerant is enters into the condenser. It is the condensation process is occurs and leaves the high pressure and high temperature of the liquid refrigerant, that is liquid ammonia only, and it is enters into the the receiver, or this is the accumulator simply. It enters into the through the expansion device, and it pressure and reduces reduces up to the evaporator level and enters into the evaporator, as like from the evaporator to the absorber. But here, the high pressure and high temperature of the liquid refrigerant from the receiver enters through the heat exchanger. It is the counterflow heat exchanger only. So that here we add some amount of the heat from the evaporator. The evaporator leaves at low pressure, low temperature of the vapor refrigerant. It absorbs some amount of the heat from the liquid refrigerant, but high pressure and high temperature of the liquid refrigerant. It is one of the major advantage, and then it is the but some heat added vapor strong solution. The vapor refrigerant is leaves at low pressure and low temperature conditions at very high heat values, and it is enters into the absorber, and here the formation of the strong solution. The strong solution in case of simple vapor absorption refrigeration system, it enters into the generator, in this generator in the case of simple one. But we place the as one of the heat exchanger, that is the ideal device only. It absorbs the maximum heat energy into the through the hot weak solution, so that it is one of major advantage. It reduce the amount of heat given to the generator, so that the cycle is repeat as usual. So here heat, we are main focused on not only the cooling system. We try to mainly focused on heat input to the generator, and maximum cooling effect. Maximum cooling effect. These are the things, and the this is the but the coefficient of performance of the heat engine, this vapor absorption refrigeration system, based on the heat values of generator and QG, QE, and QE, QC, and Q E by QC. That is the simple equation based on the thermal equilibrium of we are try to simplify the equation. The COP of the vapor absorption refrigeration system, it is depends upon all the considerations, all these considerations. That is COP of vapor absorption refrigeration system is equal to COP of vapor Carnot cycle, COP of Carnot cycle, and efficiency of the Carnot cycle, by considering of temperature limits or heat values based on the generator, evaporator, and the condenser only. So that this is very simple and very but the consideration of all the things. Thank you all of you for careful listen.